This is Calculus 2. This session, we're going to discuss representation of function as a power series. We study what the power series look like. We also discuss radius of convergence and interval of convergence. Now, we want to know what power series represent as a function that we really focus on less of this semester. So let's begin this session. Previous session, we studied power series. Power series looks like a summation n equals 0 to infinity an x minus c nth power. C is represent center, an is coefficient. When you give this power series, we find radius of convergence x minus c less than r. That's what we studied previous session. So r is here right there. R should be radius convergence. So here is a number line. This meaning is center is C, radius is R. Then if you find the x value right here, then this series converges. Then we can define this as f of x. But if x value is outside here, series is going to be diverse. So we cannot define this value. So here is very important idea here is going to be f of x. We define this function is series going to be converged. Which meaning is x is should be inside the radius convergence. Then how gonna you guys find this function? This right side is a series. Can you represent the series as a function? That's the good question mark, right? We'll see how gonna represent series as a function in the next slides. Let's talking about geometric series right here, guys. So let's talk about here before I give the geometric power series. So right here, guys, geometric series gonna be looks like summation xn. N equals 0 to infinity. I expanded 1 plus x squared. So this series has meaning, which means x should be inside interval of convergence, right? So previous session, we find the radius convergence of this power series gonna be 1. So we know this is gonna be x, absolute value of x is less than 1. We also find interval of convergence gonna be -1 and 1. So this series is converse x is. Here is a big question. We wanna represent this series as a exponential, rational exponential log or something like that. So this one is, look at this series. What happened? This one is geometric sequence. Look at this. 1 times x, x times x times x squared times x cubed. So this one is a geometric series. We can find the sum. First term is 1, ratio is x. 1 over 1 minus x. So this geometric power series represent rational function if x is between the -1 and 1. So I give the geometric power series. here is represent the power series right here. Summation n equals 0 to infinity xn. This one is center is 0, right, guys? Then this one is 1 plus x square x cubed. This is a power series at x equals 0. Represent rational function 1 over 1 minus x. Which x value? X is between the negative 1 and 1. We cannot represent this function as a power series if x is not in between the negative 1 and 1. That's very important here, right there, highlighted. Only this x value, this power series represent rational function. So we study geometric power series represents rational functions. So I'm gonna write the geometric power series right here, guys. So here is summation xn n equals 0 to infinity 1 plus x squared. That's gonna be represent the rational function 1 minus x only where x should be less than 1, greater than 1. Another way, absolute value x gonna be less than 1. So that's gonna be geometric power series. Now, from now on, we want a power series for the given function, but find the power series take a time. So sometimes very tedious step we take. So now we want to find the power series of given function by using geometric power series. You manipulate the function a little bit, then find the power series right here. So let's try this first one. They give function f of x 1 plus x. But power series, geometric power series, this one is 1 minus x. So we want to using this geometric power series to find power series for this function. So you manipulate a little bit here, guys. 1, 1. Here's a negative, right? Negative x. Make it even. So this one gonna be replaced right here. We're gonna replace x with the negative x to find the power series by using geometric power series, okay? So f of x, 1 over 1 plus x. I change a little bit algebraically. 1 over 1 minus x. This one is right there. This one is we plug in here. X is replaced with negative x. So we have using this power series absolute value n equals 0 and infinity. X replace negative x n. Okay, then what happened this one? Here is negative x gonna be negative 1 x separated. So this base you put n excuse me. Your total thing is n. Distribute the power negative 1 and n xn. So we have a new summation n equals 0 to infinity series, right? So that's you're gonna find the power series. Another important thing is here is a radius of convergence 1. We're not gonna change it. You replace x with negative x. So here absolute value negative x. Radius convergence does not change, is 1. Negative x is the same as absolute value of x. So this one is radius convergent, absolute x is less than 1. That's you find the power series of this function. Let's practice B. Let's practice B. So We did the previous one, f of x equal 1 over 1 plus x. Let's try to be. So this time, give the function f of x 1 plus x squared. So geometric power series always 1 over 1 minus x. That's going to be right this geometric power series. This geometric power series represent rational function. Radius convergence is 1. This one is rewrite this one. 1 over 1 minus x squared. This time, what are you going to replace x with what? Negative x squared, right? So we're going to do this one. Summation n equals 0 to infinity, negative x squared n. That's you're going to replace. So then what do you happen here? We practice this one, previous one. Negative x squared going to be negative 1 times x squared. So this one is a summation n equals 0 to infinity, negative 1 nth power x squared nth power. So this one is a summation n equals 0 to infinity, negative 1, 2 times n, x to n. So fx is 1 of x squared is a power series of this form. Let's do a little challenging one. So what is geometric power series? That power series represent which function? The power series looks like this one represents function 1, 1 minus x, right? So this one is look different. Guys, look at this first one. Here is a 2, here is a 1. So we want to use this geometric power series to find power series for this g of x. So we're going to change a little bit algebraically. So g of x equal 1, 2 minus x. We want to make this is 1. So you take out 2 minus, then x going to be what? We take out 2. So here is a divide by 2, x over 2. That's a rewrite this function. You're always looking for this form. 1 over 1 minus x. 1 over 1 minus x, 2. So this one going to be 1.5 times 1 over 1 minus x, 2. Right? Then you're going to replace x with x plus 2 in power series, geometric power series. 1.5 summation n equals 0 and infinity. Here is x over 2 n's power. So we're going to simplify it again very carefully, guys. Look at this. First one is 1.5 summation n equals 0 and infinity xn. Here is xn. Here is 2n. Guys, make sense? So one more time, let's simplify. 1.5 summation n equals 0 and infinity 1 over 2n times xn. So let's do a little more right here. What do you have here? 1.5, 1 over 2, and together here. This one together. So this one gonna be summation n equals 0 to infinity 1 over 2n plus 1 xn. That's you find this power series, okay? Guys, make sense, this one? Yeah, okay. Let's do this D. So looks similar. You using this power series, this function. Power series of this function, we can find the power series of this one. So find the power series from the scratch is not easy task. So always try to use the power series from the previous one. That's much easier, guys, okay? So let's try this one this time. G of x 1 over 2 plus x. So this meaning is 1, 2 minus x, right? So when you have 2 minus x, we already find you replace minus x here, right? So you have this one, summation n equals 0 to infinity 1 over 2n plus 1 times negative x n right there. So then we see this one. We practice this one is separate the base. So negative x n gonna be negative 1 and xn. So you have a new power series of this function summation n equals 0 to infinity negative 1 and n 2n plus 1 times xn. Guys, make sense? This whole example we did here by using the geometric power series to find the new power series for the given function. So main thing is you have to remember, here is right here. So geometric power series represents the rational function, this 1 over 1 minus x. Then we're going to use this geometric power series to find the new power series. Let's do more complicated power series for the given function, guys, okay? So let's try first one. First one is A. So fx, x, 1 minus x. But if you separate this form, here's x times 1 over 1 minus x. Because we know the power series of this, right? That's we want to use it. So I'm going to write this geometric power series one more time. Summation n equals 0 to infinity xn. That's represent 1 over 1 minus x, right? So 1 over 1 minus x has the power series in this form. We're going to use it. X times summation n equals 0 to infinity xn. So I'm going to put x is inside the sigma. This one is a summation n equals 0 to infinity x times xn. So simplify this exponent, summation n equals 0 to infinity xn plus 1. That's why you have power series for this given function. Guys, make sense? Okay, let's try B. Okay, so before we start, guys, this one is rewrite this function first. F of x squared 2 plus x squared times 1 over 2 plus x, right? Previous example, we find the power series of this one. Okay, so we're gonna find x squared x squared, we already find the power series of this 1 over 2 plus x summation n equals 0 to infinity negative 1 and n over 2n plus 1 xn. That's you find it. Now, here is x squared, go to inside. So you have summation n over 2n plus 1 times x squared times xn. Let's simplify this term, 2 plus n. So you have to rewrite this series, negative 1 and n, 2n plus 1, xn plus 2. That's the power series of x squared over 2 plus x. So let's do the last one, guys. So stop the video, you try to by yourself. Let's do together. Go to the C. Okay, C gonna be g of x 2 1 minus x squared. This one is 2 times 1 over 1 minus x squared. But we already find 1 over 1 minus x squared power series of this function. So we're going to reuse it. 2 times summation n equals 0 to infinity, negative 1 and n, x to n. That's you find it, right? So now 2 is going inside the sigma notation. That's going to be summation n equals 0 to infinity 2 times negative 1 and n, x to n. That's you find the new power series. Let's quick question about this power series. Guys, look at this one. This is coefficient of this power series. This power series center is center gonna be 0. That's represent function. That series represent function of g of x. So far, we learned how to find a new power series from the geometric power series. I'm gonna introduce a new method to find the power series by using differentiation and integration. So find the power series is really require a lot of work. So if you use old one to find the new one, that's really easy way to find the power series. So this example show we're gonna find the new power series by using differentiation. So we using this geometric power series right here, 1 over 1 minus x, that's the rational function, that's a summation of this geometric power series. Now, from here, we want to find 1 over 1 minus x squared. How gonna do it? You take a derivative. Okay, let's take a derivative left side first. 1 over 1 minus x. Another way you write it, 1 minus x, negative 1. So you want to take a derivative. So don't forget the chain rule. Power is negative 1. Negative 1 times 1 minus x, negative 1 minus 1 times chain rule inside derivative negative 1. So you have this one, negative 1, negative positive, negative 1, negative here is going to be negative 2. So you have 1 minus x, negative 2. That's the rational form, 1 over 1 minus x squared. So 1 over 1 minus x, take a derivative, you have 1 over 1 minus x squared. So we're going to do the same thing is right side, this power series. So now 1 plus x squared. Or summation n equals 0 to infinity xn. We're going to take a derivative. So take a derivative each term by each term. Okay, let's take a derivative. 1 derivative 0, x is 1, x squared is 2x, x cubed is 3x squared, 4x cubed. General term is nx n minus 1. So what you have to do, we want to using this one summation notation. So what is going to be summation notation looks like? This one is summation 1, 2, 3, 4, 5. So summation, here is n. N is start to 1 to infinity, x. 1, 2, 3. Power is what? 1, 2, 3, n minus 1. Okay, so left, look at this one. You take a derivative of this one, you find 1 over 1 minus x squared. You're going to take a derivative right one, you find this power series. So now our conclusion is going to be 1 over 1 minus x squared going to be power series summation n equal 1 to infinity nx n minus 1. So you use differentiation of power series to find the new power series for the function. This example, we want to show to find the power series for the ln by integration. So first, we want to find 1 over 1 plus x. We practice this one. So you find this one. Here is negative x and negative x. You plug in here, geometric power series. You find the new power series. Now, you want to find ln 1 plus x. So how can find ln 1 plus x? From here, we take integral. So integral 1 plus x dx. Then you find this one is ln 1 plus x plus c, right? Same thing is you're going to take integral right side. You want to take integral 1 minus x plus x squared minus x cubed. Okay, that's the dx. Here is 1. That's going to be x, negative x, 1 over 2x squared plus 1 over 3x cubed minus 1 over 4x fourths, right? That you find the integral both sides. So take integral left, take integral right should be same. But both sides, you very carefully, here is a c. I didn't put the c here. Don't put the c in the function. So I'm going to erase the c's right there. Then put the c is here. Okay? It's the same thing. So you have now ln 1 plus x, c plus x minus 1 and fx squared, 1 over 3x cubed minus 1 over 4x fourths. Now we want to find the c value, okay? So we want to find the c value of this. You plug in the x equals center, x equals 0. Center is 0, right? This power series you plug in. So you have ln 1 equals c. What is ln 1? 0. So you c equals 0. Now you're going to have power series for ln 1 plus x. 1 ln 1 plus x plus minus 1 and fx squared plus 1 over 3x cubed minus 1 over 4x fourths. Let's write summation notation. Guys, look at the pattern. 1, 2, 3, 4, x, n. Stop point n equal 1. Okay? Now, positive, negative, positive, negative. So negative 1 n plus 1 over first coefficient 1, second is 1 and n, third is 1 over third. So here is n. So you find the power series for the ln 1 plus x. We're going to do one more example for power series. Let's find the power series of arctangent. So arctangent, so I give the derivative arctangent to start with, but derivative arctangent 1 over 1 plus x squared. 1 over 1 plus x squared, we know the power series. This one is rewrite 1 over 1 minus x squared. So then we're going to plug in this one, summation n equals 0 to infinity negative x squared to n, then you have this one. So that's you find the power series for 1 over 1 plus x squared. Now, that's the given power series for this function. Then we find arctangent. So you have get the idea how can find the power series for the arctangent. So we're going to take integral of 1 over 1 plus x squared, gonna be arctangent. Let's take integral here. Integral 1 plus x squared dx gonna be, you say this is arctangent x. Okay, plus c, we're gonna plus c in the power series. All right, so power series right here. 1 minus x squared plus x fourth power minus x 6. Then we take integral here. Then you have 1x, but don't forget the c. Negative 1 over 3x cubed, 1 over 5x fifths, 1 over 7x 7. That's the you find the power series after integration of this power series. Now, integrate left side arctangent. Integrate power series in the right side, gonna be c plus x minus 1 over 3x cubed, 1 over 5x fifth power, 1 over 7x 7. First, you find the c value. I say plug in the x equals 0, center. Here the center is 0, so you plug in x equals 0. So here, arctangent 0 is 0. All the right side value 0 except c. So you find, now you find the power series arctangent x minus 1 over 3x cubed, 1 over 5x 7, 1 over 7x 7. Right? How can write this summation notation, sigma notation, sigma? Here is the power first, 1, 3, 5, okay, 5, 7. So x, that's odd number, 2n minus 1, n gonna be start, not 0, right? Start with 1, infinity. Sign is changed, positive, negative, negative 1, and plus 1. That the start term is positive, over. Here is 3, here is 3, denominate 5, power is 5, denominate 2m minus 1. Okay, that's the power series for the arctangent x. This session we study how gonna find the new power series from the old one. Main thing is we use geometric power series to find the new power series for the given function.